correctly. And there are really three different issues that we, as toxicologists, are concerned about with Griffitt. One is the innate toxicity of the dispersant itself, and I'll talk about that in just a minute. The other, though, is synergistic toxicity between the oil and Griffitt. Does the presence of the dispersant alter the toxicity of the oil in some way? And we'll talk about it. It does that by increasing the bioavailability of the oil to organisms. And this is a paper from Liz Kujawinski, who's at Woods Hole, that was just published a little bit earlier this year. And it's a really, really fascinating paper if you like chemistry. But basically, she used a novel way of looking for dispersant in the water. The EPA has an approved method for doing it that has a detection limit of somewhere around 2 to 5 parts per billion, which sounds really, really low. But comparatively to the method that Liz has developed, it's much higher. She can look at levels down to parts per trillion levels. And one of the things that she found, and this is kind of a schematic that I stole from her paper, is that this is what was happening without dispersant. When they're spraying it on right here, you're getting this plume forming at about 3,000 meters deep that's composed of dispersed oil droplets. Now, some of it are in here, and some of it's remaining going back up to the surface, forming the slick. But the interesting thing is that using this new sensitive detection method, she was able to find the presence of dispersant. The way she was looking technically for oil, just looked for the presence of one part of the dispersant, and found that up to 50 miles distant from the site, up to 3 months later. So it was present at relatively low concentrations, but it was still definitely there. It was hanging around for a long period of time after the use ended, and present in this discrete sort of plume. And the idea of plumes is something that's been very, very controversial, but her data is really pretty overwhelming if you get a chance to read the paper, that yes, this actually is happening. And I think she provides very, very overwhelming evidence for it. So dispersant became a media hot topic pretty quickly, and then people were very, very concerned, is it toxic or is it not? Now, the one thing you've got to understand is that anything that is allowed to be used in the U.S. has to pass through an EPA approval process. And that means they have to perform several basic standard tests to look at the acute toxicity of this proposed compound to a suite of different organisms. And it had passed that, and it had been approved, and it's classified by the EPA as slightly to moderately toxic. But given the aftermath, the public outcry of this, the EPA went back to some of their labs and said, real quickly, do it again. Just make sure, verify our results. And this is the tables that I stole from their report that they produced. They looked at 8 different dispersants, including Griffitt 9500 here and here, and they real quickly tested against 2 different species that were common to the area. Menidia, a small fish that lives in the estuaries and offshore, and a small invertebrate. So they got one small vertebrate, one small invertebrate, and they did a 96-hour acute toxicity test. And the upshot of it is that they verified the previous results. It is classed by the EPA as slightly toxic to the invertebrate and practically non-toxic to the vertebrate. And this is all well and good, but there's one thing that I want to bring up. The toxicity in this case, the endpoint they looked at was mortality. So looking at does it kill the fish or does it not. But from a toxicology standpoint, that's really a relatively minor interest. We rarely will get concentrations high enough to cause overt mortality. Much more interesting are the question of does it cause sublethal effects? Does it cause reproductive effects? Does it alter developmental or reproductive status of different organisms it's exposed to? And while you can kind of, I did it again, extrapolate from this data to that, I would be much more comfortable if we had actually had some more life cycle data available for these different dispersants. That being said, we will have that. That is being done. It's just it takes a long time to do that. Okay, so remember I mentioned the different issues that dispersants had for petroleum toxicity, and one of them is what does it do when it's in combination with the oil? Well, this is a paper that was published in 2009 before the oil spill happened, but it's still very, very relevant. If you look at the axis here, they're adding oil into water, right? They're adding it in, they're mixing it up, and then they're measuring how much is actually in the water column versus how much is in the slick. And the little triangle here and the square are WAF. Remember, that's just oil and water. There's no dispersant added. And you can see this right here, as you increase the oil at the very high concentrations, you're really getting very little amount actually in the water column, the oil in the water column. Most of it is present at the top as a slick. But if you add, this is CWAF, now this is with dispersant added in, right? And these are 2 different types. This is the Griffitt 9500, 9527. you can see that as you increase the oil loading, you get a tremendous increase in the amount of hydrocarbons that are present in the water column. So what this is saying is that the dispersion is acting as it's intended to. It's breaking down the oil slick, and it's putting the oil in the water. But again, by increasing this hydrocarbon content, you're increasing the bioavailability to organisms. And from the same paper, as you do that, as you're increasing the content in the water, you still got survival here, increasing it up to this point, you got high survival, and then immediately the survival crashes. And the point is that when you've got the dispersant present in the water, you reach these concentrations sufficient to cause mortality at a much lower loading rate of oil than you do without the dispersant. So again, this comes back to the idea of, does the dispersant, is the use of it a good idea or a bad idea? It's not that simple. It's doing what it's supposed to do. It's increasing the breakdown of the oil, but it's also increasing the potential environmental effects. So another question that I always get asked is, where did it go? That's what everybody wants to know. That's the big question. How much is still out there? How much was immediately lost? And this is a budget that was put together by NOAA. And they got a lot of heat about this. And I think somewhat unfairly so. Just viewed here, it looks very clearly as if they're saying that 75% of the oil was gone and only 26% was left. And that, I think, they got a little bit of grief over that when what they're saying is that essentially a quarter of it they can directly account for. 17% of the 4.9 million barrels they knew they drained it from the riser pipe, they collected it. About 5% of it was burned, about 3% of it was skimmed. You got all this stuff, it comes up to just about 25%, about a quarter of the total oil they can directly account for. Now the rest of it falls into different categories. One that's saying a quarter of it evaporated or dissolved. Now, evaporated or dissolved is one thing. Remember, I talked about the BTEX, the low molecular weight fractions that volatilize up into the atmosphere, got blown in by the winds, and we breathed it. There was definitely some of that occurring. We know that happens. We also have some of it dissolved. This is what we call the water accommodated fraction, again, the WAF. How much of it went directly into the water? Saying 16% of it was naturally dispersed. Again, this is mostly due to the high pressure, high velocity coming out of the wellhead into very cold water. It got naturally dispersed. And about 8% of it was chemically dispersed. This is, again, through using the Corexit, the dispersant, and dispersing it naturally. And this adds up to about half of what they know came out. And the rest they can't account for. But what I think is critical to understand is that these two categories here in particular, chemically dispersed and naturally dispersed, don't mean it's gone away. Right? It means that it's been dispersed, true, but as we've shown, I think the slide that I showed you just before, dispersed still means that it can have environmental effects. I think the people that put this slide together knew that, and if you read the paper, they made that plain. I think to a certain extent, the press that did this misinterpreted this. So I don't think that's NOAA saying that only 25% of it's there. NOAA saying that 25% of it we can't account for. These, particularly which adds up to about half of it, is potentially still available in one form or another for causing effects. So I've given you a lot of kind of hand-wavy explanations of what's going on, and why don't we know more? It's 12 months after this happened. Why don't we understand what's going on? Well, there are a couple of real good answers. One is time. Doing this stuff and doing it right takes a long time. It's a slow process, it's a laborious process, and it's always better, in my mind, to be right than it is to be quick. Now, there have been a lot of scientists that have kind of what we call publish in the press. They'll get a result and they'll run to the media and say, look what we found. And they may be right, but they really, they're running the risk of being wrong and then looking like fools afterwards. My personal opinion is I'm much more concerned about being right when I do say something than about being quick. So, and I think most people share that viewpoint. So doing this stuff is going to take time. It simply is. If you do a life cycle test on an animal that only breeds once a year, you have to wait at least a year to do it. Second reason is money. Research is expensive. If I go to Ambion or Bio-Rad and say I want to run, a microarray, they don't give me a price break because there's an oil spill. We can easily run through tens of thousands of dollars a month doing this. There's been relatively little money put into Gulf research historically. If this had happened, for example, in the Chesapeake Bay, we'd have a much better idea of what the effects were because they have a much long-term baseline of the ecology of that region. And lastly, is that some effects simply won't become apparent for years, particularly those that are due to reproductive, sublethal effects, developmental delays, adult fish being smaller, and adult fish, when they grow up and become reproductively active, having lower reproductive success, altered immune status, all these sorts of things won't become apparent for up to several years afterwards, depending on the species. So, why don't we know more? Well, we can't. For the most part, we're doing our best, though. But what do we know? Well, there are some things that we can say, either if not from this project, from analogy to others. One, correction and dispersants are only slightly acutely lethal, but lethality is not the only endpoint. You've also got to be worried about sublethal effects. The dispersant increased the amount of hydrocarbons that are bioavailable in the water column to fish and invertebrates, and this dispersed oil is more toxic than the undispersed oil would have been. But this is the big question, the biodegradation. Did the dispersant increase the biodegradation rate fast enough to kind of swamp out the effects of the increased toxicity? And again, that's an answer that we simply don't know. The question we don't have the answer to. And that's the end of my talk. If you guys have any questions, I'd love to hear them. Yeah.
BP putting money into research?
Well, yes and no. There's the $500 million, the Ocean Trust Fund that BP announced immediately afterwards. We're still waiting on that. That I think is being called up by what I've heard is political haggling. I don't know the details. That's supposed to be $50 million a year for 10 years, which is a relatively substantial amount of money. We haven't seen that yet. Some of it has been released in relatively small amounts, spread at a lot of different universities. We got some of it. We got nowhere near sufficient amounts to really do a good job with this. So I think BP said they were going to put money out there. We're all very optimistic and hopeful that we'll get it at some point. But we needed it. We needed it 12 months ago, 6 months ago.